So, welcome students, welcome to the third lecture on IIT PAL lecture series on logarithms. Today before starting the lecture, let me review the laws of logarithms. We will review the laws of logarithms, and after reviewing the laws of logarithms, what we will do is we will solve some problems and demonstrate the use of these laws. In the last lecture we have already done so. So, here we will solve somewhat elementary problems, but later on we will pick up and we will solve some complicated problems. So, now remember, we have in last class we have studied 4 laws of logarithms. The first one was multiplication law. What does this law do? If your logarithm is a log to the base a of m into n multiplied, then it actually converts it into a sum with respect to logarithm, that is equal to log to the base a of m plus log to the base a of n. Remember, all these operations are valid when a is greater than 0, a is not equal to 1, and m and n are positive numbers, positive real numbers. Okay. The next law is the quotient law, which suggests that if you have a division of two numbers and take log of those two numbers to the base a, then it actually converts it into a subtraction, that is log to the base a of m by n, which is equal to log to the base a of m minus log to the base a of n. This is called quotient law or division law, or it can be written as subtraction rule. Similarly, the first rule is called addition rule or multiplication law. Okay. Then the third law comes. This is very crucial. We have not yet demonstrated any use of this law. It is called change of base law. This will help you in simplifying many calculations. What does it do? It changes the base of the logarithm. For example, log to the base a of m, if you do not like the base a and you want to change the base a in order to simplify the calculations, then this law helps you by saying this is equal to log to the base c of m upon log to the base c of a, where c also satisfies the standard conditions, that is c greater than 0 and c not equal to 1. This law we will demonstrate the use of this law in today's class. And the last law is power law, which is log to the base a of m to the power n, where n can be any number, it can be negative also, it does not really satisfy the condition n greater than 0, it can be negative also, and therefore log to the base a of m raised to n is equal to n times log to the base a of m. This is called power law or index law, whatever you want to call. These were the 4 laws that we studied and derived in yesterday's or last class. Now we will and solve some simple problems based on this. Now we will solve more problems which are somewhat complicated and get the better idea of how to use the laws. So, today's first problem is solve for x, where the equation that is given is log to the base some unknown number x plus 3 plus log to the base some unknown number x minus 3 is equal to log 60. So, this can be any base a. So, let us put some base a, and I want to solve this problem, but here the base actually does not matter. So, how to solve this? So, we can use the product rule which we have derived in the last class, which is our first rule. It is called product law. What does it say? It says log to the base a of mn is equal to log to the base a of m plus log to the base a of n, whenever a is greater than 0, a is not equal to 1, and m and n are greater than 0. So, you have to always check whether all these conditions are satisfied. If any one of the conditions is violated, then you cannot use the multiplication rule. Another important thing is this multiplication law is with respect to the common base a. If the bases are different in the expression, then you cannot use multiplication rule. So, here the base was a, so you can use multiplication rule. As it was not mentioned, I have put this to be a. So, we can use multiplication rule, and if I use multiplication rule, this will play the role of m, this will play the role of n, then this is log to the base a of m plus log to the base a of n, then this is in fact equal to log to the base a of m into n, which is x plus 3 into x minus 3, which is also equal to log to the base a of 16. Okay. Now, let us change the color, because we have simplified. Let us change the color and try to give a solution to this problem. So, how this is done? This is done using multiplication law. That is our property 1. Okay. Now, this can be further simplified, since I am saying log to the base a of m is equal to log to the base a of n. This can happen only when m is equal to n, isn't it? So, now I will use this property and say that my x plus 3 into x minus 3 is equal to 16. What does that mean? Then you might be knowing better than me. It is x square minus 9 is equal to 16, that is x square minus 25, which is equal to 0, that is x minus 5 into x plus 5 is equal to 0, which simply means x can take two values, one is minus 5, other one is 5. Now, you remember, we are solving problems which are based on logarithms. In order to see if the logarithm is valid, we need to verify if the internal term or the argument that is given is positive or not. If the argument is negative, we cannot solve the problem. So, let us take the argument which is minus 5 plus 3, that is x plus 3 and x minus 3 is the argument, isn't it? So, x plus 3 and x minus 3 is the argument. So, minus 5 plus 3 and minus 5 minus 3. Okay. Now, if you are checking in this step, then what will happen? It is minus 2 into minus 8, right, which will become 16. So, the argument is positive. So, it may appear that the expression is valid for x is equal to minus 5, but we have not been given this question. We have been given a question which is in this form, right. So, you have to remember, this is the form of the question. So, it is not, so you have to check your argument whenever you are giving this particular expression. Now, if you are looking at this particular expression, then what will happen? Log to the base a of minus 5 plus 3 and minus 5, I am checking the first expression. So, I should write minus 5 plus 3 plus log to the base a, just check, x minus 3 and x plus 3 and x minus 3. So, x plus 3 and this is x minus 3, which is minus 5 minus 3, right. Now, the question is log defined for this particular number? Minus 5 minus 3 will yield minus 2, that means I have log to the base a of minus 2 plus log to the base a of minus 8. Now, you see the logarithm, if you are checking on some intermediate step, let us take the red color. So, you have taken some intermediate step and checked whether the logarithm is valid or not, and in this case you got 16. So, it may appear that the intermediate step, which was this, the logarithm may be valid, right. But when you actually did in the original form, what is the original form? Original form is given here and here. So, when you checked in this form, the logarithm was not valid. So, the question asked was of this form, and in this case the logarithm is not valid. So, I can check out x is equal to minus 5 is not the solution, it is not solving the expression. So, remember, these small things will make a lot of difference when you are solving the problems. If you check at some intermediate stage like this and say that since this is 16, left hand side is equal to right hand side, then my expression is valid, then you are making a mistake. This is not correct. So, you have to go to the original expression, which is this, and put in the values and check whether your logarithm is valid. This is not defined, this is not defined. Okay. Now, let us take the case 2. Let me change the color again. So, the color was green. So, okay. Now, this was case 1 when I checked for x is equal to minus 5, and what did we conclude? The conclusion was x is equal to minus 5 is not the solution. Let us take case 2. What is the case 2? X is equal to 5. So, if x is equal to 5, then again where will I check? I will check in the original expression. What is the original expression? Original expression is this. So, I will put the values in original expression, which is log of x plus 3 plus log of x minus 3, which should be equal to log of 16, all are to the base a. Okay. So, if I put this, then I get log of 5 plus 3, which is 8, plus log of 5 minus 3, which is 2, which is equal to log to the base a of 16, right. So, I can again use the multiplication rule, which I used, log to the base a of 8 into 2, which is equal to log to the base a of 16, which is nothing but left hand side is log to the base a of 16, which is equal to log to the base a of 16. These steps may appear redundant, but they are very crucial in checking whether your answer is correct or not. So, this is a correct answer. Therefore, the only answer that we have for this particular problem is x is equal to 5 is the solution for given equation. Okay. So, again I emphasize that you should not verify anything in the middle of something, right. So, we tried to verify this and we failed miserably. So, we should not do that. Okay. So, let us, so this is a learning from this particular problem. Now, let us take another problem of similar sort, but this will teach you something is what if a number is given in outside the log. So, it will be a second problem of today. I will take the brown color. So, let the second problem be, again this is also solve. So, sometimes people mention solve, sometimes they mention solve for x. What is a problem? 2 times log to the base 10 of x is equal to 1 plus log to the base 10 of x plus 11 by 10. Okay. So, I want to solve this problem. How will I solve this problem? One way is I can take the terms containing logarithm to one side and then keep 1 as it is and then apply multiplication or division rule, but I will prefer to change this term into a log term. Do we know something of this form? Can you recollect from your memory? What is 1 equal to? This we are doing from the beginning. Log to the base 2 of 2 is what? 1. Log to the base a of a is what? 1. So, log to the base 10 of 10 will be what? So, it is log to the base 10 of 10 will be 1. Okay. If you agree to that, then I can rewrite this as the right hand side as log to the base 10 of 10 plus whatever is the remaining term x plus 11 by 10. Okay. So, if this is the case, then I can rewrite this also by using the power law. What will this be? Log to the base 10 of x square, right, because this is n times log to the base a of m. So, this should be log to the base a of m raised to n. Okay. So, let me change the color now. I will put the color as green again and try to solve this problem. Okay. So, now here all the bases are same. So, I can use my multiplication rule. So, if I use the multiplication rule for this, it will be log to the base 10 of 10 into x plus 11 by 10. Hope all of you understand this. This is again as it is log to the base 10 of x square. What should be the next step? I want to eliminate these log terms. Again I will use the same logic as log to the base a of m is equal to log to the base a of n, then m must be equal to n. This is true if and only if. So, this property I will use. Then what will I get? I will get x square is equal to 10 times x plus 11 by 10. Okay. Now, this 10 will help. Had it not been log to the base 10, then we could have landed up in problems. So, now because of this 10, what I have is 10x plus 11 and this is x square. So, now it is a simple quadratic equation, x square minus 10x minus 11 is equal to 0. Can you factorize this equation? We can easily factorize this, assuming x square minus 11x plus x minus 11 is equal to 0. If you can do this, then what will be the factors? X minus 11 is one factor, and because the negative sign is retained, this factor should be x plus 1. Just check once whether I get the same. So, what should be my answer for x? X should be minus 1 or plus 11. Okay. Now, we will follow the same strategy. We have to feed back these answers into our original expression, not any expression in between. We have to feed back them in the original expression. Okay. So, for example, if you use this expression for feeding back the answer and feed the value of minus 1 here, you will get a valid log, but this is something that is not given to you, this you have converted. So, you will feed back into this particular expression. If you feed this value of minus 1 into the original expression, which is this, then what do you get? It is 2 times log to the base 10 of minus 1. This particular log is not defined. By this time you should be very clear that any negative number we are not defining. Slightly zoom out just to make sure that everything is visible. So, if this is not defined, then my case 1, which is x is equal to minus 1, cannot be there, and therefore, x is equal to minus 1 is not solution to this equation. Then I am left with only one term, which is x is equal to 11. So, if I substitute, so my case 2 is x is equal to 11. If I substitute, again you have to substitute, since this is a positive number, it will not create any problems. So, let us substitute this into this expression and verify we get the answer. So, it is 2 times log to the base 10 of 11, which is equal to 1 plus log to the base 10 of 11 plus 10, sorry, plus 11 by 10. So, it should be 11 by 10, that is fine. So, do we get the answer? Log to the base 10 of 11 square, which is 121. So, I should get this also to be equal to 121, right. So, it is 1 plus log to the base 10 of 11 into 10, which is 110 plus 11 by 10, isn't it? So, this is also equal to 1 plus, what will this value be? 110 plus 11, it should be 121 log to the base 10 of 121 by 10, right. But this is nothing but of the form m by n. Therefore, I can use the division rule or division law or quotient law we call, is equal to 1 plus log to the base 10 of 121 minus log to the base 10 of 10. Log to the base 10 of 10 is 1. So, it will cancel with this. Therefore, my LHS is equal to RHS and x is equal to 11 is the solution. So, the answer is x is equal to 11 is the only solution to this equation. Verifying your answer is very important. You have to always remember that you have, whenever you get some answer, you have to verify the answer. And let us write the third problem that we need to solve. So, here we are demonstrating the multiplication rule and the quotient rule. Now, we will try to resolve some more complicated problems like show that or something. So, now we will try to see the relationship in two variables. Suppose you have been given a question, log of x plus y upon 6 is equal to half times log of x plus log of y. Okay. And I want to, if this relation is given to you, then you need to show that x upon y plus y upon x is equal to 34. This is an interesting question. First, it teaches us something. First, you look at this expression. Let me change the color. This is the problem that is given to us. First, you look at this expression, the left hand side. Okay. So, if I have been given log of x plus y, does that mean this is equal to log of x plus log of y question mark, right? No, this is wrong, because we are never dealing with log of x plus y, we are always dealing with log of the form x into y. Now, you know log of x into y is log of x plus log of y. So, using this observation, if you look at the right hand side of this expression, then you will get something which is very nice. Okay. Then what I need to prove is a quantity which is without logs. So, somehow I have to do some manipulation so that the logs are eliminated. So, what I want in general, my guess is I need some quantity like log of some expression a b, some expression is equal to log of some other expression c d. This is what I should achieve. If I achieve that, then I will be able to do something of this form. So, let us try to do it. So, as our observation suggests that we can use the multiplication law. So, let us why don't we use the multiplication law. So, it is log of x plus y upon 6 is equal to half into log of x into y. Here I have suppressed the bases. So, you can choose any base if you want, but the base is not important here. Only thing we need to know is the base is a common base. Okay. So, whenever bases are suppressed, it is generally known that the bases are common bases. So, if I do this, then it is this way. You have to write everywhere this a. Okay. So, now I have this expression. Can I further simplify this expression? Yes, I can. This 1 by 2 is creating a problem for me. So, what I will do is I will push this 1 by 2 to this side, and that will make this particular expression as 2 times log to the base a of x plus y, okay, x plus y upon 6, this entire thing is in the brackets, is equal to log to the base a of x into y, correct. So, what does that mean? This means log to the base a of x plus y the whole square upon 6 square, which will be 36, is equal to log to the base a of x y. So, I have achieved a form which I wanted. This is the form that I wanted. So, I can use our standard rule, which is log to the base a of m is equal to log to the base a of n if and only if m is equal to n. This is the rule that I will use, and using this rule what I will get is x plus y the whole square by 36 is equal to x into y. Okay. So, if this is the case, then let us now check whether we are on the right track. What I want is something of this form, x upon y, y upon x. Can I get this? I think we are on the right track. If I expand this and divide the entire term by x y or do some manipulation, then I will get y by x and x by y. So, let us try to do it. This is x square plus y square plus 2xy is equal to, I will pull this 36 to the numerator on the right hand side, xy. Okay. Then I can guess I am on the right track, because the right hand side had some number, so as 34. I can actually get the number 34 by doing some simple manipulation, which is x square plus y square is equal to 36 minus 2, which is 34 xy. Okay. Then I am almost solved the problem, because I can divide this by xy, and what I get is x square plus y square upon xy is equal to 34. Now, this term should be the expression on the left hand side of our to show identity. So, if you take the individual terms, the first term will be x upon y plus the second term will be y upon x, which is equal to 34. This is what we desired in the beginning. Yes, this is what our identity was, x by y plus y by x to be equal to 34. Let me shrink it a bit so that everything is visible. Yes, we wanted what we got. Here there is no cross checking because you have been given an expression and you have to show that. So, if you can show that, you are done. So, this is our third problem of today. Is this the third problem? Let me check. Yes. Now, we can solve the fourth problem of today. Let us write the fourth problem of today. So, now if you notice, the problems are getting trickier. So, now the question is, if a square minus 12ab plus 4b square is equal to 0, then prove that let me write something on the next line, log of a plus 2b is equal to half log of a plus log of b plus 2 log 2. Okay. How will you prove this? Now, if you look at what is given, let me write down what is given to us. Let me change the color. If you look at what is given, it is not at all clear how to prove this particular identity. So, let me write down first what is given. You are given that a square minus 12ab plus 4b square is equal to 0, and you want to show that log of a plus 2b which is equal to half times log of a plus log of b plus 2 log 2. So, now I need to manipulate what I have to show, because this term has many logs. I know the terms which contain, I know many laws for the terms containing log. So, what are the rules that I can apply? First, if you look at this thing, I can use the multiplication rule. I can use the multiplication law. Then there is something like half and there is something like 2 here. So, I can use my power law here, power law here. Okay. And then I can simplify this expression and get the expression into form where left hand side has a log of some expression which is equal to log of some other expression, and then I can work with this, and then there is a possibility of getting this expression of this kind. So, this will be our strategy. So, let us try to apply our strategy to this problem. So, let us take this and start. So, let left hand side be as it is, log of a plus 2b which is equal to, so let us first apply the multiplication rule and the product rule together, which is equal to log of ab, which is the result of multiplication rule, and I have half over here. So, this is raised to half, okay, plus log of 2 square. Okay. This is log of 2 square. This, after using multiplication rule once more, will be equal to log of 2 square is 4 into square root of AB. which is equal to log of a plus 2b, right. So, I achieved the first target, this target is achieved. So, I can write this, let us, so I can write this as a plus 2b is equal to 4 square root of ab, but I do not like this square root because then I cannot handle many things. So, I want to eliminate this square root. Then what I will do is I will square both the sides. So, a plus 2b square is equal to 16 ab. Am I inching closer to my desired expression? My desired expression is this. So, am I going closer to it? Yes, I am. Right. So, the next step will be just to expand this, it will be a square plus 4b square plus 2a into 2b, which is 4ab is equal to 16ab. Then I got the expression. So, it is a square plus 4b square, and take this 16ab on the other side, minus 12ab is equal to 0. Yes. So, I have proved what is required to be proved. Okay. So, I started with this, I simplified the expression to such an extent that I reached the given. Okay. So, if you reverse the steps, you start with this, expand it in this manner, then go to this step, then you will get whatever is required and you will get the answer. So, this is my answer. So, I have solved the problem. Okay. Now, the next problem will be the order relation in the logs. Okay. So, now we will try to see what is the order relation in the log, or what is the actual value, what can be the value range of the values in which the log is bounded. Okay. For example, one question is to show, or show that is the question, let me write it correctly, show that two by 3 is less than log to the base 10 of 5 is less than 3 by 4. How will you prove this? And so, what is the question number here? It should be 5. 5 is the question number. So, what I will do in order to prove this inequality, I will split it into 2. First, let me try to prove 2 by 3 is less than log to the base 10 of 5, and next I will try to prove log of 5 to the base 10 is less than 3 by 4. Both of them will work on similar lines. So, I will do it parallelly. I will just put a partition over here and let us try to do it parallelly. Just choose a green color. Okay. So, here the term contains log, here the term does not contain log. How will I handle this issue? We have already handled this issue. Something is little bit invisible, but this is 2 by 3 into 1, which is less than log to the base 10 of 5. Right. What this 1 will be then? According to our convenience, it should be, I want to prove this, the question mark is here. Okay. So, what this 1 will be? Log to the base a of a, but I want, since I want to compare this with base 10, so I will put log to the base 10 of 10 is less than log to the base 10 of 5. Can I compare now? I can compare, I have to do some algebraic manipulations. So, it is 2 times log to the base 10 of 10, okay, which can be less than 3 times log to the base 10 of 5. Is it true? That is what I have to see. Do I know something about these logs? Yes, I know the power law for these logs, both of them follow the power law. So, it is log to the base 10 of 10 square, which will be less than log to the base 10 of 5 cube. Do I know something about this? So, again the question mark is this way. I know something like log to the base 10 of 100 is less than log to the base 10 of 125. Okay. Now, what do I know about what is a property of log? If m is less than n, then what will be the relation between log to the base a of m and log to the base a of n? We have already seen that the log is a monotone function. So, this implies this relation should be true and vice versa. Log of m to the base a is less than log of n to the base a, then m must be less than n. So, I can use this property and say that this relation is true, because 100 is less than 125. Therefore, the log better be smaller, log of 100 better be smaller than log of 125, and therefore, this is true, therefore, this is true, therefore, this is true, therefore, this is also true. So, we have proved 2 by 3 is less than log to the base 10 of 5. Similar thing I will do for handling this issue. Let us see how. 4 into log to the base 10 of 5, which is less than 3 times log to the base 10 of 10. So, I am just repeating the steps, so I can be little bit faster. Log to the base 10 of 5 raised to 4, which is less than log to the base 10 of 10 raised to 3. What is 5 raised to 4? 5 raised to 4 is equivalent to saying 25 square, which is nothing but log to the base 10 of 625, which is less than log to the base 10 of 1000. Right. So, is this true? Is this true? Is this true? Using this property of log, again I know 625 is less than 1000. Therefore, this must be true. So, this is true. If this is true, then this is true, then this is true. Therefore, this also must be true. So, we have proved 2 by 3 less than log to the base 10 of 5 less than 3 by 4. Let us see what is a fourth problem. Okay. So, see. So, here the problem is of equation type and I have to show something. So, the question is show that, again this also uses the multiplication rule or the division rule. Log of 50 by 147 is equal to log of 2 plus log of 5. Okay, here there is some correction, it should be plus 2 log of 5 minus log of 3 minus 2 log of 7. Okay. So, here if you notice there is no mention of base. In that case you can choose any base that you want. So, you can choose some a if you want, but the result that you are asked to prove is independent of the base. So, you cannot choose a base which simplifies the calculation, because you have to prove this result in general. So, let us try. So, there are two ways to do this problem. One is you start with the left hand side and prove that this is equal to right hand side, or you start with a right hand side and prove that this is equal to left hand side. So, let us take a brown color. So, now if you start with the left hand side, you need to find the division or the for 147 you need to find some easy numbers like 2, 3, 7, 5 or 7, right. So, this may be difficult for us. So, instead of that we can start with a right hand side and try to solve this problem. So, RHS, let us take the RHS, which is equal to log, I will suppress the base now, log to the base 2 plus 2 log of 5 minus log of 3 minus 2 log of 7. Okay. So, now if I want to show this is equal to the left hand side, I need to use multiplication rule, power law, because these terms are here. So, I need to use power law, I need to use multiplication rule, I need to use quotient rule. By this time we have since we have solved 3 problems, this should be clear. So, first step will be to put the numbers that are ahead of log into the powers. Okay. So, log 2 plus log 5 square minus log 3 minus log 7 square. Okay. So, we have put that, then we will use the multiplication law and quotient law together and say that this is equal to log of 2 into 5 square upon 3 into 7 square. Okay. Now, is this equal to, what will this be equal to? 5 square is 25, 25 into 2 is 150, log of 150, sorry, this is a mistake. So, it is 2 into 25, okay, and this is 3 into 49, sorry. So, this should be equal to log of 50 upon 49 into 3 is, naturally it should be 147, still you can calculate, 3 into 9 is 27, 4 into 3 is 12, so it 12 plus 2 is 14, so it should be 147. So, we have proved that, show that component. I think I have goofed up with numbers, so let me put the number, let me continue the current number system. Okay. So, let us put the number to be 5. And let us see, the question is solve for x, and the equation that is given to you is logarithmic expression, which is log to the base 4 of x minus 1, which is equal to log to the base 2 of x minus 3. Okay. Now, if you notice, this problem is slightly different as it has bases which are different. For one the base is 4, for other the base is 2. So, we have to be little bit careful in handling these problems, and in such problems the change of base property comes to our help. So, if you notice, the 4 and 2 have some specific relation, that is 2 square is equal to 4 or 4 raised to half is equal to 2, right. If we are using change of base property, then we have to exploit this relationship in a proper manner. So, change of base property says that if you have log to the base a of b, then it can be rewritten as log to some base c of b upon log to some base c, the base should be same here, of a, right. So, how will this property help? I want to make the bases of these two logs same. So, I will just take this particular expression on the right hand side. So, let us write down RHS is equal to log to the base 2 of x minus 3. Okay. So, this also can be written as log to the base 4 raised to half, I am using this relationship, of x minus 3. Now, the interesting part comes, I can use the change of base property. Why I am using? Because I want to change this base to the base 4, log to the base x minus 3 of some other base c to some other base c upon log to some base c of 4 raised to half. Now the interesting part is I can choose this c because c is arbitrary. So to simplify calculations I can choose this c to be 4. Okay. The same change will appear here. This is due to change of base, okay, COB, you can call it COB. If the same change appears here, then the problem becomes very simple. You already know by power law the denominator is half times log to the base 4 of 4. Log to the base a of a is 1, that also you know. So this is to the base 4 of x minus 3. So what will this yield? This goes because this will be 1 and this half will become 2. So you will get the right hand side to be equal to 2 times log to the base 4 of x minus 3. Still I cannot use the use my logarithm equality because this 2 is appearing. So I can again simplify this as x minus 3 the whole square, correct. Now what is my LHS? Because I have been given an equation, LHS is equal to RHS. So log to the base 4 of x minus 1 is my LHS. So if I write this LHS here, it is log to the base 4 of x minus 1, x minus 1. Okay. This simplifies the entire drama, and then we can always write this happens if and only if, because the bases are same, x minus 1 is equal to x minus 3 the whole square. Now this is very easy problem because you have a quadratic equation, that is x minus 1 is equal to x square minus 6x plus 9, correct. You can easily simplify this and show that this is equal to x square, you can take this to the other side, so it will be minus 7x plus 10 is equal to 0, correct. And then it is very well known, you can factorize this very easily, which is equal to x minus 5 into x minus 2 is equal to 0, correct. If that is the case, then my x is equal to 5 and 2 are the possible solutions to this problem. Possible solutions. Okay. Now what we need to do is, because we are solving an equation which involves logarithms, we have to check if we substitute the values whether they yield positive argument or not. So that is what we will do. So let us take case 1. Case 1 is x is equal to 2 and it gives log, let us take the right hand side, x minus 3, which will give you log of 2 minus 1. So log of some base, let us say 4 to the base minus 1, it is actually root 4. So this is chucked out, and x is equal to 5 is let us say log of x minus 3 to the base 2. So this is again equal to log, it's 5 minus 3 to the base 2 of 2, which is equal to 1. Therefore x is equal to 5 satisfies the equation, and x is equal to 5 is the only possible solution of this problem. To summarize today's lecture, what we have done is, today we have demonstrated the use of laws of logarithms based on the elementary problems that are associated with this logarithms. And in the next class we will again do the same thing, but we will take intermediate level problems and solve those problems with increasing level of difficulty, and again demonstrate the same use of laws of logarithms. So we will end today's session, and thanks for watching. See you in the next class.